All right, so today we're going to be doing the stream abrasion lab. So it looks something like that. All right, so if you remember, there's different types of weathering, chemical weathering and physical weathering. Physical weathering is when rocks basically break from big pieces into smaller pieces. And we said there are three different types of weathering. Frost action, where water gets into cracks of rocks. When the water freezes, it expands and breaks the rock apart. Root action is when plants' roots got inside of a rock, and as the plant grew, the roots broke the rock apart. And there was abrasion, that's where rocks collide with each other. And when the rocks bang into each other, it causes a bunch of pieces to break off. All right. Now, you can get abrasion with moving wind. You can get abrasion with glaciers. But the one we're going to focus on today is probably the most common type of abrasion, and that's the abrasion you get with moving water. So in this case, we're going to try to replicate stream abrasion. So what we're going to do is what we're going to look at is a few things. First off, we want to see is what happens to the size and shape of particles when abrasion takes place. Secondly, what we're going to look at is how different materials abrade and see if how different materials abrade. Different materials, different characteristics. All right, so what I have up here is I have 3 containers with 3 different types of rocks. And what I'm going to do is I'm going to take a plastic jar like this. I'm going to fill it up maybe about 1/3 with water. Right? The exact amount is not really important. And what we're going to do is we're going to take a few pieces of this out, and then on your paper here, you're going to draw what it looks like beforehand. And then what I'm going to do is I'm going to pour the rocks in here with water, and then I'm going to shake this for 3 minutes. I'm going to shake it for 3 minutes. So the shaking is going to represent like the rocks banging into each other at the bottom of the stream. At the end of the 3 minutes, what I'm going to do is take this, pour it through the strainer, and then we're going to look at how the particles look afterwards. And then on your paper over here, you're going to draw how the particles look afterwards. All right. So the first rock that we're going to have undergo stream abrasion is chalk. All right. You may or may not know, chalk is actually a rock. There are places in the world where there are layers of chalk. Probably the most famous chalk rock outcrop in the world is in England. It's called the Cliffs of Dover, the White Cliffs of Dover. It's these cliffs that overlook the ocean, and if you're sailing towards England, you see this like wall of white. It's just the white chalk. All right. Well, the chalk we're looking at is not white. Actually, the chalk that we're going to be doing in this experiment is green, and it's not naturally green. It's got food coloring, or it's got coloring in it. All right, so here are the rock pieces right here. And I'm going to take the camera and zoom in on this. So I'm going to show you, I'm going to do a close-up of those rock particles, and then this box right here, you're going to draw how those particles look, like a rough sketch of what they look like. All right. So here's how the particles look. All right. So you don't have to draw all 8 of them, but draw a few of them in the box on your paper. All right. That should be a good enough look. All right. So right now, these particles are very sharp and angular. Right? So if I were to draw kind of sharp and angular like that. All right, next, take this. This is just regular tap water. Fill it about a third way up. Get my timer ready. And I'm going to take these. Now, I don't want to use too much water. And the reason why I don't want to use too much water is that if I use too much water, then the rocks aren't going to bang into each other as well, because they're not going to be as close together. So drop it in there. Start the timer. And now I'm going to shake it. Now when I'm shaking it, I'm going to shake it for 3 minutes. When I'm shaking it, I want to try to be very consistent with my shaking. What happens sometimes in this lab is as people shake it, they start off with a lot of gusto and start shaking it really crazy. And then they get to the end of the 3 minutes and their arm's tired and they do it really slow. So try to maintain a nice steady shake the entire time so your results are consistent. Now again, this chalk was green. It's not the natural color of chalk. The chalk I'm using in this experiment was stuff that you buy to draw on sidewalks, so that's why it's different colors. But kind of looks like shamrock shake color right now. All right, so I'm just about over a minute in, so I need about 2 more minutes of this. I'm going to switch hands. All right, about a little over 2 minutes. All right, so it's been 3 minutes. So I put the strainer over the beaker here, and I'm going to pour the water through. All right, now So now what you want to do is I'm going to show you how these rocks look after they've been abraded for 3 minutes. All right, so what you should really notice about these rocks is a couple things. One, they are much more round than they were before, all right?
Secondly, the size of them has gotten smaller. So they've shrunken and they've gotten more rounder after abrasion, stream abrasion took place.
All right, so over here, I'll draw that they look nice. Oops. They're smaller and they were rounder. That was probably too big. They're smaller and they were rounder. All right. So when abrasion took place, the corners broke off and they got smaller. All right. Now, chalk is a rock, but it's a pretty soft rock. So we're going to try a different rock now. The next rock that we're going to look at for rock B is limestone. All right. Rock B is limestone. All right. So same deal as before. What you're going to have to do is I'm going to show you some limestone pieces, and you're going to have to draw what the limestone pieces look like first on your paper. All right. Now, limestone's a pretty common rock. A lot of times you find it used for driveways around here, or it's usually the rock they use for roads. If you have a road that's been stone and tar, they use limestone for it. So again, starting off, they're all pretty angular in shape. So now we're going to have the limestone go through 3 minutes of abrasion, just like we did the chalk. All right, let me rinse this out. Actually, don't need to rinse it out. Just use it. All right, so same deal. I'm going to fill it up about a third the way with water. Get the rocks over here and get my timer started. And here's the lid right here. Dump the rocks in. Start the timer. And I want to shake these for 3 minutes. Now, same deal. I want to try to shake it at the same rate, exactly the same way that I shook the chalk pieces. So whenever you do an experiment, you always try to limit the number of variables. So in this case, the only variable we want to look at is the difference in texture of the and characteristics of the rock. So basically, the main thing we're looking at here is that chalk is a very soft rock, while limestone is a fairly hard rock. Okay, so that's the main characteristic we're looking at to clean it. So we want to see is how the difference in hardness is going to affect the size and shape of the rocks after they've undergone stream abrasion. All right, so I've just gone over a minute. And while I'm shaping this here, I forgot to draw on the board how they look. So the limestone pieces were pretty well angular as well. Limestone pieces are pretty angular as well. All right, approaching 2 minutes. All right, so it's been 3 minutes. So I put the strainer over the beaker here. All right. All right, so here's the limestone pieces. And let's get a nice good look at these. And what you should notice about these limestone pieces is that they are pretty much the same as they were before. They really haven't changed shape at all. They're still pretty angular, and doesn't really look like they've gotten any smaller either. All right, so the limestone pieces look pretty much the same. All right. So if I was going to draw how they look afterwards, you know, I might. So pretty much afterwards, they look pretty much the same as they did beforehand. All right, the size didn't really change, and nor did the shape. And the reason being is because chalk is a soft rock, limestone is a hard rock. So the hard rocks don't change as much. Now, that doesn't mean they wouldn't change at all. What that means is if I wanted to get these all nice, like and small and round, like it did with the chalk, it just means it would take a lot more time to do that. So instead of shaking it for 3 hours, for 3 minutes, I might have to shake it for like 3 days or something like that. But if I were to shake it for a really long time, then eventually these would turn into that. It's just because they're harder, it takes more time. All right, the third rock that we're going to look at here and have undergo stream abrasion is a rock that we actually have around here in central New York. Rock salt, all right? In central New York, we have several rock salt mines in the area. All right, so here's some rock salt. And I'll give you a nice little look at the rock salt. So what you want to do is you want to draw how the rock salt looks in that before abrasion column. All right. So take a look at that, and you want to draw how these look in the before abrasion column. Yeah. So if I was going to draw these, the rock salt, I mean, they're all about the same size starting off with. The chalk, the limestone, the rock salt are all about the same size. The rock salt, they kind of look more like pellets. Just something like that. All right. Now I'm going to do the same thing again. Take this. Put about much water in there. Get my stopwatch ready. Gonna take the rock salt, put it in the water, and start her up. I'm gonna shake this for 3 minutes. Again, I'm trying to shake this at about the same speed I was doing the other ones. A little bit harder to see what's going on here because the rock salt is whitish in color, where the limestone and the chalk were darker in color. So it might be a little bit easier to see those, but you should be able to see enough. They actually make machines that do this. There's a machine called a rock tumbler. That don't have one, otherwise I'd be doing this with a rock tumbler, but it kind of shakes the rocks around. A lot of times they use them to make jewelry. You may want to make a fancy bracelet out of some rocks. So you might take some cool looking rocks and put them in a rock tumbler for a while. Because after they've been in the rock tumbler for a while, a lot of times they'll get nice and smooth. Because a rock tumbler you can leave on for like a week. So even hard rocks, if you leave them there long enough, will eventually get nice and round and smooth. So if I tried doing this for a week, I don't think I'd have much of an arm left. All right, so it's up to 2 minutes now. Minutes, 30 seconds, almost done. All right, so it's been 3 minutes. Now I pour it in here. And let's see here. All right. Now for the rock salt, what you'll notice is they've shrunken a lot in size. They've gotten rounder and smoother, but they've shrunken a lot in size. All right. So when I draw my rock salt, they make it look like that. And not all the pieces were there. Some of the pieces abraded so much you didn't really see them at all. Now, the reason why the rock salt changed so much is twofold. All right. First off, rock salt's a fairly soft rock. All right. Not as soft as chalk. It's harder than chalk, but it's a relatively soft rock. So compared to limestone, it's going to change more compared to limestone because rock salt's substantially softer than limestone is. But the main reason why the rock salt changed so much isn't so much to do with the hardness. It has to do with the characteristic that separates it from these two guys right there. And that characteristic is that rock salt is very soluble. In other words, rock salt is a rock that dissolves very easily. All right. So you actually had two types of weathering going on with this guy. So with these first two, primarily what was going on is the rocks were banging into each other, abrasion. So abrasion is what caused that. Same thing here, there was abrasion going on, but there wasn't as much of a change because the rock was harder. All right. This case, you had abrasion taking place. Again, the rock salt's fairly soft. But in addition to the abrasion, which is a type of physical weathering, you also had these rocks were dissolving, which is a type of chemical weathering. So this actually had two types of weathering taking place on it. It had abrasion, physical weathering, and it had dissolving, which is a type of chemical weathering. So because there's two types of weathering affecting this, that's the reason why it changed the most. All right. All right, so once you have your data table here with your drawings, what you got to do then is just answer the questions based on your experiment and just general questions about weathering and erosion.